50 years ago, two small spacecraft left Earth on a mission that was only ever supposed to last 5 years. Today, both of them are still flying, still transmitting, and still farther from home than anything else humanity has ever built. Between them, Voyager 1 and Voyager 2 have rewritten what we know about nearly every planet in our solar system, crossed into interstellar space, and are now sending back data from a region no human instrument had ever reached before. This is what 50 years of continuous exploration actually looks like. The story is far stranger than most people realize. Stick around, because by the end of this video, you'll understand exactly why two machines built using 1970s technology are still considered among the most important scientific instruments humanity has ever launched. Let's go back to the very beginning. Voyager 2 launched first, on August 20th of 1977, followed 16 days later by Voyager 1 on September 5th. Despite the naming, Voyager 1 was actually placed on a faster trajectory, meaning it would reach its first destinations before its twin, even though it launched second. Both spacecraft were built to take advantage of an extraordinarily rare planetary alignment, one that occurs only once every 176 years, allowing a single spacecraft to use the gravity of each, dramatically reducing the time and fuel needed to visit multiple worlds in sequence. If you're new to this channel, we cover discoveries exactly like this one every single week. So make sure you're subscribed before we continue, because the sheer scale of what these two machines accomplished is honestly difficult to fully appreciate in a single video. Voyager 1 reached Jupiter first in March of 1979 and immediately began transforming our understanding of the solar system's largest planet. Its cameras captured the first clear evidence of active volcanoes on Jupiter's moon Io, a genuinely stunning discovery, since at the time, Earth was the only other body in the solar system confirmed to have active volcanic activity. Voyager 1 also discovered a faint, previously unknown ring system encircling Jupiter and captured detailed images of the planet's swirling, chaotic atmosphere in a level of detail nobody had ever seen before. By November of 1980, Voyager 1 reached Saturn, delivering another wave of discoveries, including detailed images revealing that Saturn's moon Titan was wrapped in a thick, hazy atmosphere composed primarily of nitrogen, making it the only moon in the solar system known to have a substantial atmosphere of its own. That discovery was significant enough that mission planners deliberately altered Voyager 1's trajectory specifically to fly close by Titan for a better look, a decision that ultimately sent the spacecraft on a path angled away from the plane of the solar system entirely, permanently ending any possibility of visiting Uranus or Neptune afterward. If the sheer scope of everything these two machines accomplished is the kind of thing that keeps you hooked, do me a quick favor and hit that like button. It genuinely helps this channel keep making videos exactly like this one. That's where Voyager 2 truly earned its place in history. Because Voyager 1 had been redirected toward Titan, it became Voyager 2's job to continue the grand tour, and it delivered spectacularly. Voyager 2 reached Saturn in 1981, then became the first, and to this day, still the only spacecraft ever to fly past both Uranus and Neptune. At Uranus, in January of 1986, Voyager 2 discovered 10 previously unknown moons and additional rings circling the strange, sideways tilted planet. Then, in August of 1989, it reached Neptune, discovering active geysers erupting on the moon Triton, spewing nitrogen gas and dark material miles into space, evidence of genuine geological activity on a moon sitting in one of the coldest, most distant regions of our entire solar system. To this day, Voyager 2 remains the only spacecraft in human history to have visited all 4 of the solar system's outer planets. No other mission, before or since, has matched that single achievement. Once their primary planetary missions ended, both spacecraft simply kept flying, carried outward by momentum alone, gradually leaving the solar system behind entirely. In August of 2012, Voyager 1 crossed the Heliopause, the outer boundary of our sun's magnetic influence, becoming the first human-made object in history to enter true interstellar space. Voyager 2 followed 6 years later, crossing that same threshold in November of 2018, becoming only the second spacecraft ever to leave the solar system. Since then, both spacecraft have continued delivering genuinely surprising discoveries from a region of space no instrument had ever directly sampled before. Voyager 1 detected unexpected magnetic field distortions at the boundary of interstellar space, along with a persistent low-frequency hum in the surrounding plasma, revealing that the space between stars isn't the perfectly silent vacuum many scientists once assumed. Voyager 2, with its plasma instrument still fully functional at the time of its own crossing, confirmed that the Heliopause boundary appears to leak material in both directions, suggesting our solar system's protective bubble isn't sealed shut the way earlier models predicted. Both spacecraft have also survived genuine crises along the way, moments that nearly ended their missions entirely. In 2022, Voyager 1's attitude control system began transmitting telemetry, describing an impossible internal state, mystery engineers eventually traced back to the spacecraft accidentally routing data through a computer that had been non-functional for years. In late 2023, a failed memory chip caused Voyager 1 to transmit nothing but unreadable gibberish for nearly 5 months, a problem engineers eventually solved by creatively relocating critical software code to unused memory elsewhere on the aging computer. Each of these recoveries required extraordinary patience, given that a single command sent to Voyager 1 takes over 22 hours just to arrive, with any response taking another full day to make its way back to Earth. Today, both spacecraft continue operating on severely limited power. Their radioisotope thermoelectric generators, which convert heat from decaying plutonium into usable electricity, lose a small amount of capacity every single year, a decline that cannot be reversed or repaired. To conserve dwindling power, NASA engineers have been forced to permanently shut down instrument after instrument over the years. Difficult decisions made purely to keep each spacecraft's most essential systems and its ability to communicate with Earth functioning for as long as possible. Despite these mounting challenges, both Voyagers remain scientifically active. Voyager 1's magnetometer and plasma wave subsystem continue gathering data from interstellar space today, the very instruments responsible for many of the strangest discoveries covered throughout this video. NASA engineers have even begun testing new power management techniques, hoping to potentially reactivate previously shut down instruments and extend each spacecraft's operational lifetime a little further, buying additional time to keep listening to an environment no other mission will reach for decades to come. Both spacecraft also carry something far more symbolic than scientific instruments, the Golden Record, a phonograph disc containing greetings in 55 languages, music spanning countless human cultures, natural sounds from Earth, and diagrams showing our planet's location relative to nearby pulsars, included at the direction of astronomer Carl Sagan specifically, in case either spacecraft is ever encountered by another civilization, potentially millions of years from now, long after every trace of human civilization on Earth has faded into history. Current estimates suggest both spacecraft will likely lose the power needed to continue transmitting sometime in the early 2030s, bringing an end to humanity's longest-running, most distant conversation with the outer reaches of our solar system and beyond. When that day eventually comes, both Voyagers won't stop existing. They'll simply continue drifting silently outward, carrying their golden records forever, long after they've gone permanently quiet. 50 years is an almost unimaginable amount of time for any piece of technology to keep functioning, let alone technology operating in the harshest, most extreme environment humanity has ever attempted to send anything into. And yet, here we are, still receiving signals from two small machines built by a generation of engineers who mostly could never have imagined their creations would still be teaching us new things about the universe 5 entire decades after launch. It's worth pausing to appreciate just how much has changed in the world during the 50 years these two spacecraft have been continuously operating. When Voyager 1 and Voyager 2 launched in 1977, there were no personal computers in most homes, no internet, no mobile phones, and no digital cameras. The engineers who built these spacecraft used slide rules and early mainframe computers with a tiny fraction of the processing power found in a modern calculator. And yet the systems they designed have proven robust enough to survive 5 straight decades of continuous exposure to the harshest environment imaginable, deep space radiation, extreme temperature swings, and the sheer grinding passage of time itself, all while continuing to reliably receive commands and transmit usable scientific data across distances that grow more staggering with every passing year. That kind of engineering longevity almost never happens by accident. It reflects deliberate, careful decisions made by the original Voyager team, building in redundant systems, conservative power margins, and simple, robust designs specifically because nobody could fully predict exactly how long these spacecraft might eventually need to keep functioning. Many of those original engineers assumed their creations would go silent within a decade or two at most, once the primary planetary flybys were complete. Nobody on that original team could have reasonably predicted that both spacecraft would still be sending back usable data 50 years later from a region of space so far from Earth that sunlight itself takes over 20 hours to reach them. There's also something worth appreciating about how the mission itself has quietly evolved over time, transforming from a planetary exploration mission into something closer to a permanent, ongoing scientific outpost sitting at the true edge of human reach. Every year that both Voyagers continue operating adds another 12 months of continuous data to what is now, by a significant margin, the longest-running space mission in human history. That extended timeline has become genuinely valuable in its own right, allowing scientists to study how conditions at the edge of our solar system change gradually over years and even decades, rather than capturing only a brief, single snapshot, the way a shorter mission inevitably would. The team currently responsible for keeping both spacecraft operational looks nothing like the original engineers who built them back in the 1970s. Most of Voyager's founding scientists and engineers have since retired, and a significant number have passed away in the decades since launch. Today's mission team inherited these spacecraft, along with decades of accumulated documentation, institutional knowledge, and hard-won troubleshooting experience, carefully passed down across multiple generations of engineers who never worked alongside the original team that first designed and built these two remarkable machines. Looking back across the full 50-year arc of this mission, it's worth remembering just how differently things could have gone. Either spacecraft could have suffered a catastrophic, unrecoverable failure at almost any point along the way, during the intense radiation exposure near Jupiter, during the extreme cold of the outer solar system, or during any of the genuine engineering crises both spacecraft have already survived in more recent years. Instead, through a combination of careful, original engineering, dedicated ongoing maintenance from Earth, and what can only be described as remarkable resilience, both Voyagers have continued their journey largely uninterrupted, quietly, rewriting the record books for how long a single spacecraft can realistically be expected to operate. That resilience carries real weight for the future of space exploration, too. Every lesson learned from keeping these two aging spacecraft alive for 5 decades, every creative software workaround, every careful power management strategy, every diagnostic technique developed to solve seemingly impossible mysteries from billions of kilometers away, feeds directly into how engineers design and plan future long-duration missions. Spacecraft, currently being designed for eventual missions to the outer solar system and potentially even beyond it someday, will benefit directly from everything. The Voyager program has taught engineers about survival, resilience, and creative problem-solving across truly extreme mission timelines. There's a reason NASA continues prioritizing the Voyager program's remaining operations, even as its budget and staffing have been repeatedly scaled back over the decades to reflect its aging status. No other mission, currently flying or even currently planned, will reach interstellar space again for many years to come. Every single day, either Voyager continues transmitting, represents additional, genuinely irreplaceable data about a region of the galaxy that remains almost entirely unexplored by any other means. That scarcity alone justifies the continued careful effort required to keep two nearly 50-year-old machines talking to Earth for as long as engineering ingenuity and dwindling power reserves will possibly allow. If two spacecraft built using technology from the 1970s can still be making genuine scientific discoveries 50 years later, farther from Earth than anything else humanity has ever built, what do you think the next major surprise from either Voyager is going to be before their power finally runs out for good? Drop your thoughts in the comments and let me know which Voyager discovery from this entire 50-year journey surprised you the most. If this deep dive into the full scope of the Voyager missions is the kind of content you want more of, hit that like button. It genuinely helps this channel keep making videos exactly like this one. And subscribe if you haven't already, because these two spacecraft are still out there, still transmitting, and we'll be covering every new discovery as it comes in. 50 years after leaving Earth, two small machines are still out there in the dark, still listening, still teaching us things nobody expected them to still be capable of teaching, carrying humanity's voice farther into the galaxy than anything else we've ever built, and quietly proving that 50 years may not even be the end of this remarkable story.